Okay, AP Chem, today we're going to learn about plating metals, which is the next step in the electrochemistry unit. So during electrolysis, electrical energy is converted into chemical energy. This is the reverse of the process that occurs in the galvanic cells. So remember, we went over those electrochemical cells, and the ones that happen spontaneously are called galvanic cells. And the ones that don't happen spontaneously are called electrolytic cells. So this is called electrolysis. Electrolysis has a variety of industrial applications. And one of them, which we're going to go over today, is called electroplating. There's also things called electrorefining, which separates metals into different parts, and also recharging secondary cells. So non-spontaneous reactions are forced to occur in electrolytic cells by passing electrical current from an external power source through an electrolyte. Remember, an electrolyte is only a substance that conducts electricity. The potential energy of the system is increased as the electrical energy is forced into the cell. So in galvanic cells, the reactions are separated, so electrons can be used as they're transferred. That's how we gather that electricity. Electrolytic cells have two electrodes and an electrolyte. Electrolytic cells are different from galvanic cells in that the anode is the positive electrode while the cathode is the negative electrode. I realize this can be super confusing. The polarities of the anode and cathode change because galvanic cells, the polarity is imposed by the reactions themselves. So at the anode, electrons are produced, and the cathode, electrons are consumed. In electrolytic cells, the polarity is imposed by a power source. So this pulls electrons from the anode and forces electrons into the cathode. Regardless of which cell you're talking about, electron always flows the same from the anode to the cathode. Oxidation always occurs at the anode and reduction always occurs at the cathode. Remember our red cat and our ox, they are the same here also. So here's the difference. Remember, we did the galvanic cells, those spontaneous reactions where you have two cells separated and you gather the electricity that is produced from the chemical reaction. In an electrolytic cell, you're going to plug it in or provide some sort of power source in order to add electrons to the chemical reaction. So we're going to talk about electroplating. So in this case, the cathode is coated with a thin layer of metal from a solution containing ions of that same metal. So this is done to improve the appearance or prevent corrosion by the application of a protective layer. So in general, you might take a cheaper, more prone to corroding metal and then coat it with a more expensive and less prone to corroding. It makes a metal object prettier a lot of times and stronger and more resistant to rusting. So in order for this to occur, in order for you to lay a thin layer of one metal on top of another metal, the electrolyte is a complex mixture of ions and conditions such as voltage, current, and time, and it has to be carefully controlled. So here's an example of what it might look like. Let's say you had a spoon that you wanted to plate with silver because silver is an expensive, soft metal. You oftentimes see things being coated with silver or plated with silver instead of the object being pure silver. Another thing you might see with silver is alloys. Another thing is electrorefining. Metals can be purified by electrolysis. So metals are better conductors, they're stronger reductants, and will be discharged at the electrode surface. So this is another application of electrolysis, a little bit different than electroplating. So here's an example of what happens. So let's say you had a metal that was impure. What you'd want to do is dissolve it, and then the impurities will stay in the solution, and the copper, which you want, will plate in a purer form. Here's another application of electrolysis, is to get sodium from molten sodium chloride. This is called a down cell. Okay, we're going to talk a little bit about Faraday's laws of electrolysis. If you wish to electroplate an object, you might ask yourself the following questions. How do I determine how much metal is being plated? How long should I leave the object in the electroplating cell? And what size electrical current should be used? So this is Michael Faraday again. He talked a little bit about electrolysis. He studied, if you know anything about physics, he studied electricity a lot and electrical currents. So this law enables us to work out the amount of energy required to discharge a metal ion and plate it out on an object, or to calculate the amount of metal produced in an electrolytic cell. So here's our equation. Charge, which is Q in coulombs, equals current in amps and time in seconds. This will let us calculate the electrical charge passed through a cell from the measurements of current and time. This is a conversion factor. 1 Faraday is 96500 coulombs. In order to produce 1 mole of a metal, 1, 2, or 3 moles of electrons must be consumed. So that depends on the charge on the metal. So for example, lead 2 has a charge of +2, that would take 2 moles of electrons. Aluminum has a charge of +3, that would take 3 moles of electrons. Silver has a charge of +1, that would take 1 mole of electrons. So here's our equations. The number of moles of metal ions, the charge on an ion, times 1 Faraday. In order to produce 1 mole of a metal, 1, 2, or 3 moles of electrons must be consumed. So silver +1 would take 1 mole of electrons, copper +2 would take 2 moles of electrons, chromium +3 would take 3 moles of electrons for discharge. The quantity of electricity required will be, so the amount of charge, remember charge is measured in coulombs, N stands for the number of moles of metal ions, Z stands for the charge on an ion, and F stands for Faradays. So let's go back and remind ourselves what they stand for. So charge is in coulombs, current, which is I, will be in amps, and T is going to be time in seconds. So you can see that we just rearranged and replaced in these equations. So the equations that you see here are all the same. Just take a note and make sure you understand what each of those variables stands for. And that's what you should have in your notes, is the variable, what they stand for, the units that they are measured in, and then these 3 equations, which are all related to each other, they're just substituting into each other's equations, can be used to do a series of problems. Here is 5 problems, and when you read through them, just say calculate the number of moles of copper ions. So now you know that you're solving for moles of copper. That's going to be N. And then the current of 5 amps, which is going to be I, and the voltage of 6 Vs for 10 minutes. Now remember that time has to be in seconds, so you would have to do that conversion. So see how you do walking through these problems, and in our next video, we will create an answer key for these problems.